Okay, these are your notes for Chapter 8, Section 1. The idea with this is we are doing direct variation. Okay, this is 8.1. All right, direct variation or proportionality. Okay, so they follow a particular set. Your book uses the expression y is equal to mx. Okay, and so we call this direct variation, y is equal to mx. Our only qualifier is that m is not equal to 0. It is also called your constant of variation. Okay, so direct variation has a particular thing. X is your independent variable. Okay, y is your dependent variable. Okay, the idea is when x goes up, y goes up. That's what direct variation means. Or when x goes down, y goes down. So that's what direct variation means, is they directly relate to each other. Okay, so you're not going to have a lot of problems to do with this, but I'm going to go over a few setups for them. These are directly out of your book on page 356. Okay, so I'm going to read them out instead of write them out because they're all set up like word problems. So page 356, this is number 2. It says if the sales tax on a purchase, on a $60 purchase, so we got $60, it's our purchase, is X, and our in the sales tax is actually $3.90, we have a relationship. We know sales tax works as if when your cost goes up, your tax goes up, right? So when X goes up, Y goes up. So we have this form, Y is equal to MX. All right. The question they ask is, what is the tax on a $280 purchase? So when X equals $280, what does Y equal? Okay, so we do this by going through and setting up our equation. So we take y and we take x, right? And we take those and we plug them into this equation. Y is equal to mx. All right, so if I do that, I've got y, which is $3.90, equals m times x, which is $60. All right, and so we just divide by 60 and we get a value for m. Okay, so we get 3.9 divided by 60, which is equal to 0.065. Okay, that is our constant variation. So to answer our question, we want to know y when x is $280. Okay, and so we do 0.06 times, or 0.065 times 280, and I get $18.20, and that's your answer. Okay? All right, let's look at another example. This is number 4 on the same page. 4. Same page. All right, the acceleration of an object varies directly. Okay, so it tells us varies directly as the force acting on it. So we've got acceleration varies directly as the force. I'll use a capital A. Okay, all right, so if a force of 240, so we've got a force of 240, causes an acceleration of 150 meters per second squared, all right, we can solve for m. So 150 divided by 240, okay, that's equal to 0.0625. Okay, we've got our constant variation. Now we answer the question, what force will cause an acceleration of 100 meters per second? So we have acceleration of 100 per meter second squared. We have an m of 0.0625, and we want to find the force. So we do 100 divided by 0.0625. And that equals 1,600, and I think we're in newtons. Yeah, newtons. So our units are newtons for force. Okay, and I'll do one more, and then I'll tell you what your homework is that you need to try to do before you come to class next either Monday or Tuesday, depending on if you're in first or fifth. This is number 8 on the same page. Okay, the public opinion poll found that of a sample of 450 voters, okay, 252 favored a school bond measure. Okay, so we've got voters, 452. Y favored it, 252. Okay, if 20 persons voted, how many are likely to vote for the bond measure? Okay, sorry, 20,000 people voted. So we need to find M. And this follows Y is equal to MX. We're trying to find the proportion of voters who voted for it. So one way to do that is we can just say M is equal to Y divided by X. Okay, so that's 252 divided by 450. Okay, so 252 divided by 450 is equal to 0.56. That's the same thing as if I plug in down here for 252 is equal to M times 450. Remember, you divide by 450, so you get 252 divided by 450. All right, so that's the same thing. So there's our M. Okay, so I can just find my new voting amount. Y equals M, which is 0.56, times 20,000. Okay, so 0.56 times 20,000 is 11,200 voters. Okay, that's how many people they think will vote for this particular measure. Okay, that's direct variation. Your homework that I will expect you to have done before you come to class on Monday or Tuesday is page 356, 1 through 9 odd. Okay, that's 5 problems. You should be able to do that before you come in. I'll take any questions you have, but it's pretty straightforward in regards to direct variation. So that's it for direct variation. Next one we'll cover different types of variation.